Honeywell sensing business have manufactured optical liquid level sensors for many years, in fact a few decades. Last year they announced the obsolescence of their standard temperature sensors, which went from I think -20 to +80 Celsius, and recently they announced the obsolescence of the high temperature range, which go from -40 to +125 Celsius. The sensors which are now obsolete came in 4 different housing styles. There was the Type 1, which has got a short M12 threaded section. The Type 2, which is longer and has a parallel section after the thread and goes into the tank or the application a little bit deeper. Type 3, which mounts from the inside of the tank and the threads on the back, again an M12 thread. And finally the Type 5. And the Type 5 sensor was designed to push into a hole from the inside of a tank, and there's really no method of keeping it in place. Once it's pushed through, you would typically maybe glue it to hold it in place. Anyway, those sensors are all obsolete now, and people are looking for alternatives. Well, the good news is that SST has been manufacturing optical liquid level sensors for well over a decade as well, and we have a very wide range of sensors. And we have a range of sensors which will certainly, in general, replace the Honeywell sensors. From an electrical point of view, they are identical. They work off the same supply voltage range, which is 5 volts to 12 volts DC. The difference is that the SST sensors can drive more current. The Honeywell ones typically can only drive a couple of milliamps, in some cases up to 10 milliamps in others, depending on the product range. All of our sensors in our similar range, which we call the Optimax range, they can all deliver 100 milliamps syncing and sourcing. The housing styles we have available is the equivalent to a Honeywell Type 1, we call it an RLC 100 style. It has an M12 thread as well, and it has a hexagonal section at the back. As you can see, the hexagonal section is significantly longer than on the Honeywell one. The reason for that is simply to fit in the electronics which allow us to do the higher power switching. Type 2 is very similar to the Honeywell one. It's virtually identical except for it has a cone rather than a dome, which I'll come to in a minute. The Type 3 is very similar again. Again, we're slightly longer at the back, although people don't tend to care about that end in the application. And finally, our equivalent to Type 5, it has the same dimensions in general. Directly behind the shoulder here, there's a very precisely toleranced 10mm section which can push into a tank. We've also got a thread, which means you can put a nut on the back to seal it, and you can maybe put a washer as well, or an O-ring. Again, we're longer than the Honeywell one at the back, but electrically we're identical. To serve the North American market, we also designed what we call a Type 6, which is a 1/2 inch -20 UNF thread, which can accommodate an O-ring here. And finally, the Type 7, which is a 1/4 inch NPT, so it's a tapered thread. Our sensors come with all the same accessories as the Honeywell ones do, in other words, a washer and a nut. So pretty much they're drop-in replacements. Now, I mentioned briefly that the Honeywell sensors have a dome and our sensors have a cone, and that's the fundamental difference in the way the sensors operate. There are some benefits to the dome, there's some benefits to the cone. Generally, we find the cone is more reliable. Sometimes the dome is generally better where you have a reflective surface very close to the sensor, but we can get around that with some software adaptations in this sensor if we like. Because all of our sensors have a microcontroller in them, we're able to add features. We can make the sensors more or less sensitive to different liquids, overcome the effects of condensation, and all that good stuff. We can also add delays, for example, so you might have a sensor in an application where liquid's going up and down, and you don't want the sensor constantly toggling on and off. Well, we could put a 5-second delay in there so that only once it had been in air for 5 seconds or in liquid for 5 seconds, uninterrupted, would the output actually change state. So that's basically the difference. The other thing we can offer as well is this material called Trigamid. So all of the Honeywell ones I talked about and most of our standard sensors come in a material called polysulfone. It's a high-grade engineering plastic. It's impervious to many, many liquids. But sometimes there's a chemical which is going to attack and degrade the sensor, in which case we can offer Trigamid as an alternative. That's also NSF approved for food and beverage applications. It's not necessarily a better plastic, it's just a different plastic that's good at things that polysulfone's not good at. So for example, people often use polysulfone in diesel fuel, but they would use Trigamid in gasoline. So that's really it. We've got a complete range of sensors. We can do the same temperature ranges as the now obsolete Honeywell products, the same voltage supply. We use less power actually than certainly the Honeywell standard temperature sensors used to use, and we can deliver more output power. So you can do more with the sensor and you can make it drive bigger loads. So we hope to hear from you soon and hear how we can help you with optical liquid level sensors. Thank you.